Okay, so this is problem 8 from chapter 6. And what we have here, we have a 330 kilogram piano. It slides 3.6 meter down, a 28 incline, and is kept from accelerating, so it does not accelerate even though it slides down. So it's kept from accelerating by a man who is pushing back on it parallel to the incline. So the idea is basically the following. This is the incline, this is our ramp. We have here piano, which is sliding down, but it's preventing, there is a man pushing it and preventing it from accelerating. Okay, so this man is pushing it, so I'm going to put this force applied by the man against the motion of this piano, which is sliding down. Okay, now comes a sequence of questions, but let's point out what are the parameters that are given to us. We have the mass of this piano. We have the distance that is going to fall, this displacement along the ramp. We also have the angle of this incline. And they also give to us the coefficient of kinetic friction. All right, so we have all of these quantities. And the first question is the force exerted by the man. So to find this force exerted by the man, which we already drew there in red, we need to first start drawing all of the other forces. So let's try to do that. And so we have the force applied by the man. We also have the weight of this piano pointing down towards earth. Since the piano is touching this ramp, touching this surface, there is normal force, and the normal force is perpendicular to the surface. And we also have friction. They gave us the coefficient of kinetic friction. So in which direction should we draw the friction force? Well, the piano is sliding down, so the friction force is against the motion. So we have the friction force also in this direction. So you see that the force applied by the man and also the friction force are against the actual motion of the piano, and they both contribute to prevent this piano from accelerating. Very well, so let's go for the first question. As we said, the first question is, what is the force applied by this man? This force is in the x direction. Well, it's in the x direction because I already anticipated the frame that we are going to choose. As we have discussed before, a good frame of reference in this kind of problems when the objects are sliding down is this one. If we ever get acceleration, we don't need to decompose the acceleration, correct? So this is the x direction, and that's why I said that the force applied by the man is in the x direction. Okay, so let's write all the forces that we find in the x direction. We have, according to the frame that we chose, minus the force applied by the man. We also have minus the friction force, and we have a component of the weight. To write down what is the component of the weight, we need to think a little bit about the angles. This is the angle theta that is given to us. If we were to think about a triangle, we know that this angle here that the weight does with the edge of this ramp is 90 degrees. And so we know that this angle here is 90 minus theta. As a result, this angle here is theta since x and y are perpendicular. Okay, so with that, we can add the component of the weight for this equation, which will be positive mg sine of theta. This is the component of the force that really brings the piano down. Now, since they say that there is no acceleration, even though the piano is sliding down, there is no acceleration, so the piano is sliding down with constant speed, we know that this equation is equal to 0. Okay, so from this equation we can find the force applied by the man. This force is mg mg sine of theta minus the friction force. And now, to give an answer, to give a number, we need to know what is the friction force. Very well. The friction force, as we know very well, is mu, the constant coefficient, the coefficient of kinetic friction multiplied by the normal force. And what is the normal force in this problem? Okay, to find the value of the normal force, we need to have a look at the equation in the y direction. So let's go for the equation in the y direction. What we have in the y direction, we do have the normal force that we are after. And we also have a component of the weight. And the component is minus mg cosine of theta. So from this equation here, well, this is equal to 0. There is no movement in the y direction, right? From this equation, we know that Fn is equal to mg cosine of theta. So now we can go back to our equation for in the x direction and try to find the force applied by the man. What we have then is the force applied by the man is mg sine of theta. The normal force here gives us mu mg cosine of theta, correct? So the force applied by the man is mg sine of theta minus mu cosine of theta. All of the ingredients to get a number you have. All of the quantities here you have the mass, g, the angle, and the coefficient. So which are found here. So you're done with part A of the problem. Part B of the problem is the work done by the man on this piano. The work now. We found the force, so we can then find the work. Now, remember, the force that the man is applying is anti-parallel to the displacement. So to find the work done by this man, I need to put here a negative sign because the force is against, is anti-parallel to the displacement. But that's all that we need to remember. Now I put the force applied by the man, which we already computed, multiplied by the displacement, which is given by the problem. Okay, let's go to the next part of this problem. Part C of this problem is asking us the work done by the friction force. All right, so the work done by the friction force, similar to the work done by the man, involves a force that is anti-parallel to the displacement, so we need to remember to put that minus sign. And that's it, because the rest we already have. It's the friction force multiplied by the displacement. The friction force we already found here with when we computed the normal force. All right, let's now see what is the next question, and this one now is the work done by the force of gravity. The force of gravity, the component of the force of gravity that slides this object down is in the direction of the motion. So this one will be positive. And so to find the work done by the force of gravity, what we need is the component of the force of gravity along the displacement, along the x direction, and this one is mg sine of theta multiplied by the displacement, and this one is positive, as we said, because the force is in the direction of the displacement. Okay, the last question of this problem is, what is the net work done on the piano? So if I take into account all of these different works that we computed, all of these different forces that are applied on the piano, what is the net work? Well, this you can immediately say 0. You don't need to compute anything. You can just say 0 because the speed that this object is sliding now is constant. So if it's constant, there is no net force. If there is no net force, the net work is 0. But of course, it's a good check for you is to put on the numbers and be sure that all those numbers were computed correctly. So to get this net work, you can put the work done by the man the work done by the friction force and the work done by the force of gravity, and you should double check that this is indeed 0.